We would work. We can work through some of these examples of that. So, for example, let's say that we have in this triangle here, and of course, not all of this will be to scale, but that's okay. We have A equals 5 and B equals 12. Using our formula for Pythagorean Theorem, we have C squared equals 5 squared plus 12 squared. So C squared is 25 plus 144. Then C squared is 169. And because, again, anything greater than, than 12, I'm not going to necessarily have them memorized. Although 169 is pretty common, I suspect it won't take long before most students realize that 13 squared gives you 169. Again, positive or negative, but I can't have a side that's negative 13. So in that case, I would indicate which one I'm talking about there. So in this case, the hypotenuse has a length of 13. Could be centimeters, meters, inches, whatever the unit is in the work. And you do want to be sure to use your units. If it gives units, be sure and include those units in your answer. That can be an easy way of losing a couple of points on a problem there. Let's take a look at a slightly different example. Let's say we have A equals 9, and this time the hypotenuse, the length of the hypotenuse is given. Again, we take these numbers and we plug them in here. We have 15 squared equals 9 squared plus B squared. Okay? 15 squared is 225. 9 squared is 81. Keep the B squared. We want to wait to work on getting rid of this exponent once we've isolated it by itself on one side. So the first thing we're going to want to do, excuse me, that should be equals, is again, this goes back to that algebra review, the basic algebra we did, where you would subtract anyone from both sides. And that's going to end up giving you 144 over here, and keeps the B squared by itself. Again, the way you handle a variable, solve for a variable that's squared, is you take the square root of both sides. I didn't demonstrate that over here, but we did talk about that during the review. So you take the square root of both sides, and you have B equals plus or minus 12. Again, can't have a negative side length. Positive is the value you're looking for. So in this case, this leg here is 12. Its length is 12, whatever the units might be for the problem. So there's two common examples of Pythagorean theorem at work. Okay, so let's take a look at one more example that's a little bit more, in my opinion, a little bit more real world. In this case, let's say we have a wall over here, and of course it meets the ground. And assuming, I think it's usually a pretty safe assumption that most walls are going to connect with the ground at a right angle, give or take a little bit. But for the purposes of this sort of calculation, that would be fine. And you have a ladder that, by safety standards, has to be at least 6 feet away from the wall. And this window here is 10 feet high. 10 feet denoted by the little hash mark there. Now we have units, so this is a good example with units. And now that you have, so we have a ladder here that has to be 6 feet from the wall to meet safety standards, and the window is 10 feet up. And the question is this ladder long enough to reach that window? Or more specifically, how long does the ladder need to be to reach the window given these dimensions? So what we have here is the ladder here constitutes the hypotenuse, or C. And the other two sides, it's not necessarily, it doesn't necessarily matter which one you denote as A or B. You can use different variables for that matter. You could use X, Y, and Z. A common one I learned when I was in school, obviously, was C was H. Helps you remember which one is hypotenuse. But common practice today is A, B, and C for right triangles. So we'll just stay with the common vernacular. So what we have here is, we know that C squared is going to be A squared plus B squared. So C squared equals 10 squared plus 6 squared. So I have C squared equals 100 plus 36. So C is, C squared equals 136. And so C is going to be the square root of 136. Again, the positive value, obviously. We wouldn't have a negative lateral length. And again, in this case, we have an example of a number that does not have a perfect root, a perfect square root. So what we would want to do in this case, you can approximate. Obviously, you can bring out your calculators. You might want to designate the standard two decimal point rule, and you can use your calculator to come pretty close. We know from an earlier problem that 15 squared is 225. 10 squared is 100. So we know that this is going to be between 10 and 15, closer to 10 than 15. 12 is 144. That's still a little more than that. So it's going to be between 10 and 12. Between 11 and 12 as it works out. In this case, of course, like I said, you can get within two points of the decimal, and we'll call that pretty accurate. So we would want a ladder that's at least 12 feet tall, that can at least extend itself to 12 feet in order to safely be able to access that window of a burning building. So this is an example of a sort of real-world application that you could use for Pythagorean Theorem. So typically at this point in the class, I probably lectured about 15 minutes would be my guess, with the review and this and everything. So we've occupied between the bell ringer, the review, and the lecture, we've probably taken up about 20 to 30 minutes of class. So at this point, I would have the students come up and work some example problems on the board. It's a great way to get a bird's eye view and see where the struggles are, where some students are having difficulty with the subject matter. Because of limited board space, again, I would have maybe divide the class into 3 groups, and one at a time bring the students up and see if we couldn't get them to work, and maybe have the other groups from their seats, the other members of the group, help coach them through if they start to struggle, see if they can't help. One thing we know is that students learn differently from their peers than they do from a teacher, and encouraging that, I think, is a great way to keep the students engaged in the class. So that would be kind of a typical day. After we did maybe 10 or 15 minutes of board work, I would then pass out the assignment, and it's going to be part of the lesson plan that's in my portfolio, and so I would pass copies of this out. Any questions that they had we could deal with, maybe some in-class tutors, students that are really doing well in the class can help some of those that are struggling with some of the math involved and some of the algebra involved. So have them work, spend the last 10, 15 minutes of class, however much time is left, working through it. You know, bell schedules vary these days. Most classes are between 45 and 55 minutes, though I've heard of some lasting as much as an hour and a half. So, but typically for a 55 minute class, this would be how that would happen. Take care of the bell ringer. Typically the bell ringer is going to be about 10 to 15 minutes. Lecture for about 15 to 20 minutes, which includes about a 5-minute review and a 5-minute introduction, and spend the bulk of the time doing examples. I think when, I know for me, when I see things done, it falls into place a little bit better. Maybe even have a handout of the lecture itself that you can pass out, so the students can continue to familiarize themselves with the material as it was presented and what they'll need to know for the assignments and for the quiz, maybe the next day's bell ringer, the end of the week quiz, and the major test that'll be coming up, 2 weeks hence. So they can keep themselves familiarized with this and continue to work on that. And so that would be the typical day. Again, 10 to 15 minutes for a bell ringer, about a 15 to 20 minute lecture. 10 to 15 minutes on the board, and the last bit of time in class, anywhere from 5 to 15 minutes, I would think, would be done passing out the homework, going over it, making sure everybody understands what's due, and answering any questions that they have. And again, using those in-class tutors if that's something that's available to me, and conducive for that particular school, and the administration is okay with it, then I can incorporate some of those students who are doing really well in math and know this material, use them as sort of in-class tutors in that last 10 to 15 minutes, keep them engaged in it too. And that would kind of be the end of the day. So I hope you enjoyed the presentation. This is my lecture on Pythagorean Theorem. Thank you.